Hello all, welcome to the another concept on software engineering, that is called design concepts. So in design concepts, okay, so what is design in the context of software engineering? So what is the design process like? Software quality guidelines and attributes we need to follow for the design process, and the evaluation of software design, how it has been evolved over the time, and different design concepts like abstraction, architecture, patterns, separation of concerns, modularity, information hiding, and functional independence, and refinement, object oriented design concepts, and design classes. Okay, then we will see few design models, okay, which are data design elements, architectural design elements, interface design elements, and component level design elements, finally deployment level design elements, okay, with a few examples. Okay, so let's start with the design with the context of software engineering. Okay, so software design, okay, which is after we have taken the requirements and we analyze them. Okay, the end product of this analyzing the requirements, taking the requirements, is the design. Okay, and the starting of the coding. Okay, before starting of the coding, with the help of this design only we can able to do that. Okay, so once software requirements have been analyzed and finalized, okay, that means modeled. Okay, so the design is the last action, okay, which is in the modeling activity, and that can set the stage for construction. Okay, that is generating code or writing code, and validating code, that is testing the code. Okay, so here you can see the example, how we would translate the requirements, okay, into the design model. How we would translate the requirements model into the design model. You can see we do have a few design models here: scenario based elements, flow oriented elements, behavioral elements, and class based elements. How they have been converted into the design model. Okay, if you observe data class design, okay, which I have taken from the class diagrams and collaboration diagrams and CRC models, right? So if you take the architectural diagrams, which has been contributed with the help of class based elements as well as flow oriented elements. Okay, so same interface design has been contributed with the help of behavioral elements and flow oriented elements and scenario based elements, right, and so on. This is overview of this picture, gives us the overview of how requirements model has been converting into the design model. Okay, yeah. So design in the context of software engineering helps us to tells us that the data or class design transforms, which we have seen in the figure, okay, into a design class. Okay, and that requires the data structures which is required to implement the software. Okay, here the objects and relationships which are defined in the class relationship context diagrams, the detailed data, okay, which is depicted by the class attributes and other notations like methods. Okay, these are will be main action for the design. Okay, so some part of the class design, okay, may conjunct with the may differentiate with the design of software architecture, but so more details of the class, okay, more details of the class design occurs as each software component is designed. Okay, yeah, the most Richard Dew tells us that the most common miracle of software engineering is that transition from analysis to design and design to code. That is the most common miracle in software engineering. Next, coming to the architectural design, okay, which defines the relationship between the major structural elements of the software and the styles, architectural styles and design patterns, okay, which are used to achieve the requirements, okay, defined for particular system which you are going to develop. Okay, the constraints which we see that the way we look at them, okay, with the help of the architecture design can be implemented. Okay, this architectural design which represents with the framework of computer based system which are derived from the requirements. Okay, yeah. Next one is interface design. Okay, that can able to describe you know how the software communicates with the systems which are internal to the system or external to the system. Okay, so here the interface implies that flow of the information like data or control and data and control and specific type of the behavior. Okay, so hence we can say that usage scenarios and behavioral models can able to provide much of the information that requires for the interface design. Okay, yeah. So CAR Hore said that we do have two ways of constructing the software design. One way is to make it simple, and the other way is to make it as a complicated as we can. Okay, that is CAR Hore has described. Yeah, the last and finally the component level design. Okay, which transform the structural elements of the software architecture into procedural description of the software components. Okay, so the information what we obtain from the class based models or flow based models and behavior models, which are serves as the basis for component design. Okay, yes. If you see the software quality guidelines and attributes, throughout the design process we need to follow few software quality guidelines and few attributes, which are described by the McGlunian. Okay, so there would be three characteristics that are very core to the this evaluation of good design. The first one is the design must implement all other explicit requirements which are in the requirements model, and it must accommodate all other implicit requirements, so which are desired by the stakeholders. Okay, that is the first characteristics of three characteristics. And second one is the design must be readable, and in the sense it should be readable and understandable, so that who generate code, that means who write the code, and who going to test that code which is generated and subsequently support the software. Okay, so last and final characteristics of the this design model is evaluation of good design is so the design should provide a complete picture of the software, which addresses the data in the functional and behavioral domains from the implementation perspective. So here are few quality guidelines, you could able to see that. Okay, so whoever developing the system should follow. Okay, the first one is a design should that can able to expose or exhibit an architecture that has been created using recognizable architectural styles or patterns. Okay, that means already existing architectural styles or patterns should be used for to exhibit the design of the architecture. Okay, and second one is it is composed, the architecture is composed of components that exhibit good design characteristics. Okay, so whatever the components in your architecture should follows the good design principles, and characteristics. Okay, and the third one is the architecture can be implemented in a evolutionary fashion. Okay, thereby it can able to facilitate the implementation and testing. Okay, these are three what we can say is guidelines or for this designing the architecture. Okay, the second one is a design should be modular. Okay, whatever the design you are doing should be module. Okay, so that the software should be logically partitioned into elements of subsystems. So what happens if you design your system in a way like a modular means, if you are encountered any problem with the any if your system, you could able to identify where problem has been located with these modules. Okay, which module giving you that trouble. Okay, that is the advantage with the modularity. Okay, and the third one is a design should contain contain distinct representations of data. Here distinct representation of data in the sense data would be represented in a manner that human generated, and system generated, and like that, right? That a design should that distinguishes representation of data, architecture, interfaces, and components. Okay, so these are the few software quality guidelines. Okay, and few more are, a design should lead to data structures that are which are appropriate for for the classes which are to be implemented, and drawn from the recognizable data patterns. All right, and fifth one is, a design should lead to a components that exhibit independent functional characteristics. Okay, so our design should be should have the components, that can able to exhibit independent functional characteristics. Okay, and the sixth one is, the design should lead to interfaces that reduces the complexity of connections between components as well as external environment. Okay, so whatever the interface you want to design with your system should not be complicated, and should not so complex to interact with outside or within the components of the system. Okay, and the design should be derived using repeatable methods, that is driven by information which you obtained during the software requirements analysis. Okay, so the design should be derived using the repeatable methods, which are actually driven from the requirements which you have taken during the requirements analysis. Okay, and eighth one is, a design should be represented using notation that effectively communicates its meaning. Okay, that might seems simple, but that actually the core guideline for the software quality guidelines. Okay, design should be represented using notation that effectively communicates its meaning. Okay. We do have quality attributes for designing the context of software engineering. Okay, HP, Hewlett Packard, they developed some set of software quality attributes. Okay, so they gave a acronym as a FURPS. Okay, FOPS. Okay, FOPS in the means, F means functionality. Okay, so functionality is the attribute that can be assessed by evaluating the feature set and capabilities of the program. Okay, so generality of the functions that are delivered, and the security of the overall this system. Okay, quality isn't something we lay on top of subjects or objects. Okay, like Christmas tree, tinsel, like that. Okay, so next one is usability. In the second letter represents usability. Okay, usability can be assessed by human factors. Okay, overall ethics and consistency and documentation. Okay, whether the design of your system, whether your interface of whether the interface of your system can able to reach to the customers, it can be usable or not. Okay, and the R in the sense means reliability. So how do you measure the reliability? Okay, by measuring the frequency and severity of failures, so that can occurs by during the system usage. Okay, so if you are facing many errors, in the sense means the failure rate of your system might very high, and we could say that is not reliable to use. Okay, and we need to use a measurement called MTTF in the sense means mean time to failure. Okay, so that can able to identify how much time that can give you the average time of the failures which is occurs during the system during the time. Okay, the ability to recover from the failure also one more measurement that could be considered in these quality attributes, right? So that is reliability. Next one is performance. Okay, how do you measure a software system performance? Okay, so based on speed, obviously, response time, resource consumption and throughput and efficiency. Okay, these are the attributes we could able to take to consider the performance. And the last and final word is the supportability. Okay, so it can able to extend the program extensibility, adaptability, and serviceability. Okay, so these three attributes represent represent the term called maintainability, okay, and testability and compatibility. Okay, so ease with which a system can be installed and the ease with which problems can be localized. Okay, so these are attributes that can able to indicate the supportability of the system. So FOPS means you can easily say that functionality, U means usability, R means reliability, and P means performance, S means supportability. Okay, we need to remember these attributes with the help of the short term definition called FOPS. Okay, so yeah, next one is the evolution of software design. Okay, the evolution of software design began in the beginning of 90s. Okay, that starting of conventional software design, which we discussed in early chapters like waterfall model. Okay, later it has been evolved into V-shaped model. Okay, then it has been evolved into iterative model. Okay, like that. Okay, so here you can see procedural aspect of design definition evolved into philosophy called structured programming. Okay, so later that methods of translated into data flow or data structures. Okay, and that would be converted into design definition. Okay, so yeah, then after new design approaches came after that can able to propose an object oriented approach to design derivation. Okay, so in more recent ways design has been on a software architecture and the design patterns that can be used to implement the software architecture, and few lower levels of design abstractions are came into picture late 90s, right? Then some emphasis on aspect oriented methods. Okay, growing emphasis on aspect oriented methods. Okay, model driven development. Okay, test driven development emphasize techniques to achieve more effective modularity. Okay, and architectural structure in the design that are created. Okay, so all of these methods, okay, whatever we came across, okay, all these methods might have some few common characteristics. Okay, so what are those? Okay, mechanism for the translation of the requirements model into design representation, that is one common characteristics across all the design models. And second one is a notation for representing functional components and their interfaces. Okay, and third one is heuristics for refinement and partitioning, and guidelines for quality assessment. Okay, so yeah, almost all the models which we came across might contain these four characteristics. Okay, so you can see these are the whatever you are seeing is the generic task for design, whatever their design you want to implement. Okay, those might follow these tasks. Okay, so yeah, before we enter into the design concepts, a set of fundamental software design concepts has been evolved over the time. Okay, degree of interest in each concept has been varies. Okay, and that means changes over the years. Okay, so almost all of them has stood time tested. So each provide each design provides the foundation which more sophisticated design methods can be those methods can be applied. Okay, so each help us to answer for few questions. Okay, so the questions might be, so what criteria can be used to partition software into individual components, and how can you function or data structure can be able to give the details which are separated from conceptual representation. okay, and what is the criteria which is uniformly define the technical quality of software design. All right. So yeah, Jackson said, okay, so the beginning of wisdom, for anything, okay, software or software engineer, to recognize the differences between getting a program to work and getting it right. Okay, so yeah, that is the main wisdom. Okay, getting program run is different from getting right kind of getting it done right kind of task. Okay, yeah, fundamental software design concepts, okay, which are can able to provide, okay, some necessary frameworks for getting it right. Yes, fundamental software design concepts make your design getting it right. Okay, the first concept in design first thing in design concepts are the abstraction. Okay, so when we consider about the modules, okay, so there might be many level of abstraction would be there. Okay, highest level of abstraction, so the solution would be stated in a broad terms, using the common language, okay, with the problem environment. Okay, so then later if you go to the lower levels, okay, of abstraction, okay, so that there you will find more detailed description which is more compared to the higher level of abstraction. Okay, then if you go to the more lower, more deep into the abstraction, you will find each and every details of the problem in that abstraction. Okay, so these are three levels of the abstraction. Okay, in the first higher level abstraction you will find just few details. Okay, in a few words, okay, you will find the problem. Okay, in the lower level of abstraction you will get some more details which is more compared to the higher level of abstraction, and the more if you go more lower level you will get each and every details about the problem. So Grady Butch, okay, one of the textbook author, says that abstraction is one of the fundamental ways that we as a humans cope with the complexity. Okay, yes, next one is, yeah, so we do have a different levels of abstraction which are developed, okay, to create both procedural and data abstractions. Okay, so procedural abstraction is something, a sequence of instructions that have a specific and limited function. Okay, so name of the these procedural abstraction that can able to imply these functions are but these are specific details are suppressed. Suppose example for this procedural abstraction is the word open for a door. Okay, so it is a single line of command says word open for a door. Okay, so to open a door you need to go to the door. Okay, I mean if it is having steps, you need to step down the door or step up the door to the door, and grasp the knob and open the door. Okay, so that is simple example of procedural abstraction. Coming to the data abstraction, it is contains the collection of data that describes a data object. Okay, so coming to the procedural abstraction, we will say that open the door. Okay, that contains some few instructions which are hidden in the statement, but coming to the data object, data abstraction, there it will contains the data. For example, what kind of door it would be, what is the size of the door, what is the direction of door open, and what would be the lock type, and so on. These are the measurements or attributes that are related to the data abstraction. Okay, so yeah, so we discussed procedural abstraction as well as data abstraction. Okay, software architecture tells us that the overall structure of the software and the ways in which the structure provide conceptual integrity for a system. Okay, that is what architecture told us in design concepts. architecture telling us that the overall structure of the software and the ways in which the structure provide conceptual integrity for a system. Okay, that means architecture is the structure of structure or organization of a programming components or modules, we could say, in a manner which these components interact with each other. Okay, and deals with the data. Okay, so are used by the few components of the architecture. Okay, so in broad way we could say that components can be generalized to represent major system elements of and their interactions. Okay, so the main goal of this architecture is in terms of design, to derive the architectural rendering of a system. Okay, how it working in a broad way. Okay, so how rendering services will be work throughout the system, and the framework from which more detailed design activities are conducted. Then what are the different architecture patterns, okay, that can enables us the as a software engineer to solve common design problems. Okay, all these are the main goal of the architecture. Okay, what Len Boss tells us that a software architecture is the development work product that gives us the highest return on investment with respect to the quality, schedule, and cost. Shaw and Gerlin, okay, they describe few properties okay, that should specify to the architecture design is structural properties. Okay, so this aspect of this structural properties aspects represent or design the and define the components of system, like modules, objects, and how objects are interact with each other, and if there are any filters. Okay, and the manner in which those components are packaged, okay, and interact with one another. Okay, that is what structural properties tells us. Okay, sometimes for example, objects are packed into a single entity. Okay, that means encapsulation, we could say that both the data and the processing that manipulates the data and interacts, how they interact with each other via the invocation of methods. Okay, everything will be represented with the structural properties. Next one is extra functional properties. Okay, so description of the architecture design, okay, that can able to address how the design architecture achieves requirements for the performance. Okay, capacity, reliability, security, adaptability, and few more characteristics. Okay, that is done with the help of extra functional properties and families of related systems. Okay, so this architecture design may draw with the help of repeatable patterns. Okay, so which are commonly encountered in the in the design of families of familiar systems. Okay, that means there might be a design which was already drew and implemented, so we could able to take the pattern which was implemented in that design, so we call it as a pattern, and we are also we can able to follow the pattern. Okay, if it is if we think that the suitable for our system. Okay, the design should have the ability to reuse architectural building blocks. Okay, when we use the patterns, design patterns. Okay, next one is structural methods. Okay, that they represent architecture in an organized collection of program components. Okay, that is with the help of structural models. Next one is framework models. So that can framework models increase the level of design abstraction by attempting to identify repeatable architectural design frameworks which are encountered in similar types of applications. Okay, so these are few things we could say that okay, these are few things that can describe the set of properties which are specified in architectural design. Okay, Next one is patterns. Okay, so as you know, just now we discussed about patterns. Okay, in pattern means something which is which conveys the essence of proven solution to a reoccurring problem. Okay, with a certain context, midst of competing concerns. Okay, like that. That means repeatable solution for reoccurring problem. Okay. So what design pattern describes us is, it designs the structure that solves a particular design problem with a specific context, and in the midst of forces that may have impact on the manner in which the pattern is applied and used. Okay, so that is about the patterns. And so the main intent of this design pattern is to provide the description that can able to help us to enable the designer to determine whether this pattern is applicable to the current work or not. Okay, so and this pattern can be reused, okay, or not, okay, for future enhancement. And this pattern can serve as a guide for developing a similar but functionally or structurally different pattern. Okay, yeah, so we need to ask these questions when okay, a design pattern is when we are using the any pattern which we think are suitable for our system. Next, separation of concerns. Okay, it is a design concept actually, okay, that suggests us that any complex problems can be, okay, so more easily handled, okay, if if it is whatever the system is subdivided into different pieces. Okay, so each of these pieces can be solved or optimized independently. That is what separation of concerns telling us. Okay, okay, the main concern here in this separation of separation of concerns is behavior which we specified as a part of the requirements model. Okay, for the software. Okay, and so by separating the concerns, okay, into a smaller parts, okay, more manageable pieces of a problem, which is less effort and time to solve. Okay, if you divide the problem into similar small pieces, that would take a lot of time to solve each and every piece, right? Here you can see this example that this tells us that if we have two problems, P1 and P2, and their complexity is P1 is greater than the P2. Okay, the effort is the effort it would take is something which is greater than the entire effort we put on the system. Okay, that is what they are trying to tell us. Okay, yeah, separation of concerns is that can be manifested into different related concepts or design concepts. Okay, so modularity and aspects and functional independence and refinement. Okay, so that is all about separation of concerns and modularity. Okay, so modularity is the most common thing of separation of concerns, okay, which we discussed just now. Software might have divided into different addressable components. Okay, sometimes we call them as a modules. Okay, those are integrated to satisfy problem requirements. Okay, so modularity is the single attributes of the software that can allow us the program, okay, to intellectually manageable and operatable. Okay, so monolithic software, okay, large program which composed of single module, okay, can't be easily grasped by a software engineer. That is very difficult, right? Number of control paths, okay, of of number of variables, okay, overall complexity, okay, would make that makes the program highly impossible, okay, to understand. Okay, so almost all instances, okay, if you try to break the design into many modules, okay, hoping that you can able to solve them easily, and okay, but the consequences is the cost required to build the software very high. You can see this diagram here. If the number of modules are increasing, then the cost of effort would also be increased. Okay, so here number of modules should not be more, and the cost of effort also will be increases. Okay, here this is the middle point, is the region of minimum cost there. So average number of modules will affect us the cost of the effect. So next one is information hiding. Okay, so yeah, it is related to information hiding is what we can, with the help of abstraction we can do that. Okay, sorry, encapsulation we could do that. Okay, so which is characterized by the design decisions. Okay, each of them hides information from all others. Okay, so module should be specify and design so that information contained with the module is inaccessible to other modules that have no need for such information. Okay, yes. Yeah, hiding implies that the effective modularity can be achieved by defining a set of independent modules that can able to communicate with one another, okay, with the help of the information which is necessary to achieve the software function. Okay, so abstraction helps to define the procedural entities that can make up the software, and hiding defines and enforces which acts as constraints to both procedural details within a module and any local data structure which is used by the module. Okay, yeah, the information hiding, okay, with the help of with the use of information hiding, okay, which is as a design criteria for modular systems that can able to provide the greatest benefits when we modify it. Okay, when we modify the modules, okay, during the testing, and after the testing also, after the maintenance also, we can able to very useful. Okay, most data and procedural details are hidden from other parts of the software. Okay, so that helps invariant errors which are introduced during the modification, which are less likely to be propagated to other locations within the software. Okay, yes. Functional independence. Okay, so here the functional independence in the sense means, okay, so direct outgrowth of separation of concerns, okay, which is modularity and the concepts of abstraction and information hiding. Okay, so what few papers which are in software design tells us that is refinement techniques that can able to enhance module independence, which is most probably with the help of Stevens, Mayers, and constant solidified the concept. Okay, so this functional independence is achieved with the help of developing modules, okay, single-minded functions, okay, and aversion to excessive interaction with other modules. Okay, yeah, okay, with we can able to achieve the functional independence. Okay, so we should define software so that each module addresses a specific subset of requirements which has to simple interface, okay, when we viewed from other parts of the program structure. Okay, yeah, cohesion in the sense means indication of the degree to which a module focuses on just one thing. Okay, yeah, software with effective modularity, okay, which is independent modules, okay, are easier to develop because functions can be compartmentalized, okay, and interfaces are simplified. Okay, independent modules are easier to maintain, okay, because secondary effects which are caused by design or code modifications are very limited. Okay, error propagation also reduced, and reusable modules are possible, right? To summarize, functional independence is the key to good design, and design is the key to software quality. Okay, so that is how functional independence helps us there. Okay, so functional independence is assessed using two qualitative criteria. So one is cohesion and coupling. Okay, cohesion is, as we mentioned earlier, cohesion is the indication of relative functional strength of module, so that performs a single task, okay, which requiring a little interaction with other components in other parts of program. Okay, so they stated simply a cohesive module should just do one thing. Okay, next one is coupling. Okay, coupling is the indication of the relative interdependence among the modules. Okay, sometimes it is necessary that one software component might perform multiple functions. Okay, components components that combines modules that perform any unrelated functions are to be avoided. Okay, if a good design is to be achieved. Okay, here as we come to the coupling, okay, which is the indication of interconnection among modules, okay, in a software structure. Coupling is completely depending on the interface complexity between modules. Okay, the point at which every reference is made to a module and what data pass across the interface. Okay, simple connectivity among modules, okay, which results software that is easier to understand and less prone to a ripple effect. Okay, which is caused when errors occur at one location and propagate through the system. Ripple effect in the sense means one error occurs that can able to propagate to all the modules of the system throughout the system. That is called ripple effect. Okay, so in the design concepts, the final refinement in the sense means it is a top-down strategy, okay, which is proposed by Nicholas Wirth. Okay, a program is what he says is a program is developed by successfully refining levels of procedural details. Okay, hierarchy is developed by decomposing a macroscopic statement of function, okay, in a stepwise fashion until programming language statements are reached. Okay, so this refinement is actually a process of elaborating the design. Okay, so we start with the beginning, we start with the statement of function, then we will define the high level of abstraction in there for that function. Okay, abstraction and refinements both are complementary concepts. Okay, so abstraction enables us to specify a procedure and data internally, but suppresses the need for outsiders, okay, to have the knowledge of low level details. Okay, coming to the refinement, which helps us to reveal low level details, okay, as a design progress. Okay, both concepts, okay, allows us to create a complete design model as the design evolves. Okay, next one is refactoring. Okay, refactoring in the sense means, okay, it is one important design activity that may contains many this activity contains many agile methods. Okay, so refactoring is nothing but reorganization of the technique, okay, that can able to simplify the design. Okay, or a component, simplify the design of a component, okay, without changing its function or behavior. Okay, so what Fowler defines refactoring in the sense means it is the process of changing a software system in such a way that it does not alter the external behavior of the code or design, it improves its internal structure. That is what refactoring, which is defined by the Fowler. Yeah, when software is refactored, okay, the existing design is examined for redundancy, okay, unused design elements and inefficient or unnecessary algorithms, poorly constructed or inappropriate data structures, any other design failures that can be corrected to yield a better design. Okay, here you can see the example. So the final result will be software that is easier to integrate, easier to test and easier to maintain. Okay, so coming to the design concepts, object oriented design concept, which is widely used in modern software engineering. Right now, if you take any project mainly these concepts are using object oriented design concepts. Okay, so that contains classes, objects, inheritance, messages, and polymorphism, and others. Okay, so design classes is this is a part of object oriented paradigm, okay, which are as we mentioned widely used modern software engineering. Okay, so over design concepts, okay, object oriented design concepts as a classes and objects, inheritance, messages, and polymorphism among others. Okay, so next one is design model. Design model can be viewed in two different dimensions. Okay, the process dimension and the abstract dimension. The process dimension indicates the evaluation of the design model as a design task which are executed as a part of the software process. The abstract dimension represents the level of details as each element of the analysis model is transformed into a design which is equivalent and then refined iteratively. Okay, yeah, here you can see the simple diagram that can able to see analysis model and design model, how they will be represented. Okay, low and high abstract dimension with low and high. Okay, so these elements of the design model mostly uses the same UML diagrams which we used for the analysis model. Okay, the difference is these diagrams are refined and elaborate as a part of the design. Okay, so these design models are more specific details, more implementation specific details are provided, and architectural structure and style and components that resides within the architecture and interfaces between these components and with the outside world are all emphasized. Okay, so in most cases preliminary architecture design which sets the stage and which is followed by interface design and component level design, okay, which are occur in parallel. Okay, the deploymental model is actually usually delayed until the design has been fully developed. Okay, so we could apply all these design patterns at any point during the design. Okay, so these patterns enables us to apply design knowledge to domain specific problems that have been encountered which are solved by others. Okay, first thing is data design elements. Okay, data design elements, okay, which creates a model of data or the information that is represented at a high level of abstraction, and this data model is then refined into progressively more implementation specific representations, okay, that can be processed by the computer based systems. Okay, so many software applications, the architecture of the data will have profound influence on the architecture of the software that must process it. Okay, the structure of data has always been important part of the software design, as it is very important. Okay, the program at the program component level, okay, the design of data structures and the associated algorithms which are required to manipulate is essential to the creation of high quality applications. Okay, so at the application level, the translation of data model into the database is very important, that plays pivotal to achieving the business objectives of a system. Okay, so at the business level, the collection of information which is stored in a disparate databases and organized into a data warehouse, okay, which enables data mining or knowledge discovery that can have an impact on the success of the business itself. In every case, data design plays an important role. Okay, next one is architectural design elements. Okay, architectural design for software is the equivalent to the floor plan of a house. Okay, that architecture model is derived from the three sources: information about the application, domain for the software to be built, specific requirements model elements such as data flow diagrams or analysis classes, their relationships and collaborations for the problem at hand, and the availability of architectural styles and patterns. Okay, the architectural design element which is usually depicted as a set of interconnected subsystems, okay, which are often derived from analysis packages within the requirements model. Each subsystem may have its own architecture. Okay, Next one is interface design elements. Okay, so interface design of our software is, which is analogous to set of detailed drawings, okay, like doors, windows, external details of a house. Okay, so interface design elements for software depicts the information flows into and out of the system and how it communicates among the components defined as a part of the architecture. Okay, there are three important elements of the interface design: the user interface, external interface to the other system devices, networks and other producers or consumers of information, internal interfaces between various design components. There are these interface design elements allow the software to communicate externally and enable internally communication and collaboration among the components, okay, that populate the software architecture. Yeah. Coming to the interface design elements. Okay, so UI design, user interface design, is a major software engineering action. Okay, usability design that incorporates aesthetic elements like layouts, color, graphics, interaction mechanisms, ergonomic elements like information layout and placement metaphors, user interface navigation and so on, and some technical elements like patterns, UI patterns and reusable components, okay, which are part of the interface design. We need to take care of in these interface design elements. Okay, actually UI user interface is a unique subsystem within the overall application architecture. Okay, so actually there are three parts of the interface design elements are there. Okay, user interface to the system external to the application, like other actors or other entities approaching to the system, and interfaces to components within the applications. Okay, how within the application interact with each other. Okay, so the design of external interfaces that requires definitive information, that is about entity to which information is sent or received. Okay, in every case the information should be collected during the requirements engineering itself, okay, and verified once the interface design commences. Okay, the design of external interface should incorporate error checking and appropriate security features. Okay, the design of internal interfaces, which is closely aligned with the component level design. Okay, design relation of analysis classes that represent all operations and the messaging schemes which are required to enable communication and collaboration between operations and various classes. Okay, so each message must be designed to accommodate the requisite information, the transfers and specific functional requirements of the operation that has been requested. Okay, what Douglas Adams says, that a common mistake that people make when trying to design something completely foolproof was to underestimate the ingenuity of the complete fools. Okay, next one is component level design elements in the design model. Okay, the component level design of the software is the equivalent to a set of detailed drawings. Okay, for example, if you come to the room in a house, okay, you will draw the room room size and doors and where the windows would be, every detail will be in there, right? So here also, coming to the software engineering, the component level design for the software is fully described the internal detail of each and every software component. Okay, to achieve this, component level design defines data structures for all local data objects and algorithmic details for all processing that occurs within the component, and any interface that allows access to all the component operations. We call them as a behaviors. Okay, so Charles Eames states that the details are not the details, they make the design. Okay, here you can see the simple example for our safe home security application, that is sensor management to the sensor. Okay, how we represent the component level design, component level elements with the help of UML component diagram. Okay, next one is deployment level design elements. Okay, last one is the deployment level design elements. Okay, These elements indicates how software functionality and subsystem will be allocated within the physical computing environment that will support the software. Okay, deployment diagrams begins with the descriptor form, where the deployment environmental where the deployment environment is described in general terms. Okay, later the instances form is used to, and elements of the configuration are explicitly described. This is the example of safe home security, where each and every component will come, what we can say is encapsulated in a particular diagram. Okay, you can see different components, how each and every components would be in a particular a particular box. What we can say is how they interact with each other, particular objects. Okay, and each and every component contains different components again. Okay, so all this information which we have taken from the software engineering a practitioner approach by Roger S. Pressman. Okay, so thank you very much.